this computer. So recording chat, do you see a record thing on your end? No. Yes. Yes. No? Well, good enough. So just a warning, so just a reminder, if you ask a question out there, this microphone may pick it up. So you may be audible on the YouTubes and on the Echo. And in chat, you should just give me your messages through text-based. I'll keep an eye on it. So today we're going to talk about functions, which in my opinion should have been like the very first thing that we talked about. Because you guys have been, like everything you touch in Python is essentially a function. Like plus is a function that takes two integers and gives you an integer back. Multiplication, print, right? Basically everything that you've touched except for keywords have been functions. So it's important that you understand this because writing code and separating it into various functions which do things is like the essence of programming. Right? You're writing code and you're saying, oh, look, I just happen to be doing this exact same thing over and over and over again. Maybe I should make that a function, and that's going to simplify my code base, right? Because every time you see 8 lines that are similar, that can now be replaced with 1 line. The other advantage of this is that when you take a problem and you sort of break it apart into simpler pieces, each of these little pieces should themselves be functions, and then you can go ahead and start testing these functions. And then you take those functions and you connect them to be something bigger. Right? So this notion of doing something small, ensuring that it's working, and then connecting it with something else to make it do something a little bit more and make sure that's working and moving up, that's sort of software development, right, in a nutshell. So let's just remind ourselves that the order that we write code in is important, right? And I'm saying this because at the beginning, I had this lecture and I said there are only 3 things really that you need to do all computer programming: sequencing, selection, and repetition. So repetition, while loops and for loops. Selection, that's when we had if statements where we could say code go this way or go that way or even skip something. I'm sort of saying functions fall into this sort of sequencing. So executing the same commands in a different order will produce different output, right? So if I say x is 1 and y is 2, and I just do it like this to save vertical space. I have more horizontal space than vertical space on these slides. So this just sets x to 1 and y to 2. If I set x equal to y, and then y is equal to x, what is the values of x and y? You say they're both 2? Or are you saying peace among you? I am not a crook. Okay, so 2. Let's check this out. So x gets 1, and y gets 2. This means x gets overwritten with 2. This means y gets 2. So both of these things are 2. Okay, I'm going to do the same thing, but I'm just going to permute line 2 and 3. I'm going to say y gets x, and x gets y. Now what are the values of x and y? Well, let's walk through it, right? X gets 1, y gets 2, y gets 1, and then x gets y, which is 1. So both of these things are 1. And so the exact same commands in different order will do different things. And that's incredibly important, right? The order that we do things matters. That's not the case in every type of programming paradigm, by the way. In some declarative languages, like functional languages, order is irrelevant, right? So it's important that you know that this is one way of instructing a computer, but not the only way. I know all of you know what a function is, because that's all you've been shown in math up to this point. Right? So this is normally how you would think of a function, right? You have f of x, which is a parabola, and I'm sure if I said, what is f of 3, you'd be able to evaluate it. So what are the important things about a function? A function is basically an instruction that when you give it some input, it will return some type of output. Well, how is this an instruction? Well, this is an instruction that says, give me a number, and then I'll return to you something which is that number squared plus that number plus 1. Right? X squared plus x plus 1, that's a series of instructions. A mathematical one, but a series of instructions nonetheless. So I hope you're all comfortable with these types of functions and evaluating them. Right? So what is this function? What is f of 0 in that function? 1. Okay, perfect, right? Because it got input, 0. So if I write f of 0, it's going to go 0 squared plus 0 plus 1. Now, this may seem totally trivial, but what I want to say is how functions work in Python is like exactly the analogy to how they work in math. It's simply an instruction to map input to some type of output. So here's the simplest type of function that we can create, which is just the one that represents that f of x. So if you think about what we need to tell Python, we're going to have to say, need some provision to say, I want to define a function. So that's what this def is here for. I'm saying this is a keyword that's reserved for saying, look, I want to give you a series of code, but this code should all be bundled and considered the same function. Right, so remember, spaces matter. So there's like 4 spaces here, which indicates that everything 4 spaces out of this definition will belong to this function. And you see this other word here called return. Every function should have a return in it. There's something that every year I can't seem to stamp out of new programmers' heads. And this is the difference between returning from a function and printing from a function. You always return from a function. There's hardly ever a reason to print from a function. We're going to go over like maybe half a dozen examples where I'll flesh this out. But if you have a function and you don't have a return, you've done something wrong. So these are the constituent pieces. A def, the name of your function, followed by inputs to this function. And then you can do an arbitrary amount of stuff, and then finally you return. And this keyword is saying, yep, this is the thing eventually that you should like hand back. Right? So sort of to say f of 2 here, it's going to return what it's doing over there. So let's get out of this math example and try something else. So I just want to remind you again that Python is a language where spacing matters. Right? Spacing is sort of denoting what pieces of code belong to what structures. So the 4 spaces here indicate that this belongs to this function. If I had more lines, several lines, right, that tabbing would also indicate that it's part of that function. If you get errors along the lines of indentation error, then check your tabbing. You may get this a bunch. Okay, so here's another simple function. This function takes 2 inputs. Right? You can take as many inputs as you'd like. So this one takes x and y, and it's going to return x times y. Now, this is the reason people print. If I say x is equal to f32, what value gets stored in x? These aren't trick questions. I'm just trying to keep you guys awake. Let's look at what's happening here. So 3 and 2 get passed to this definition. So x becomes 3, y becomes 2, and we return 3 times 2, which would be 6. Right? So this function is... this will become 6, so the value 6 gets stored in x. Okay, so 6 is in x. Right? If I ask, what is x? It's going to say 6. But that shouldn't have actually shown anything. It doesn't, just because you don't see 6 doesn't mean it hasn't been computed. Actually, I don't, this may be a typo. Let's just go in and check. So I'm going to define a function foo, x and y. 1, 2, 3, 4 spaces, return x times y. So I can do stuff like this, right? 3 times 19. And I can also say x is equal to foo 3 times 19. And the point I'm trying to make, so that other slide, I'll have to correct it a bit. It didn't print anything. Right? So people say, oh, this couldn't have worked, right? I'm expecting to see 3 times 19. But I'm saying x is equal to 3 times, x is equal to 3 times 19. It's like the value is in x. We can look at it. Right? But if you set x to the result of some function, it doesn't, did I call it foo? Right? It doesn't necessarily print anything. Now let's try to do the same thing with the print. Okay, so, right? This looks like it's working. It's multiplying numbers together. So let's write another one called bar. And it's going to do the same thing, but instead of returning, I'm going to print. Okay, so let's see. Bar 1, 2. Oh, okay, bar 3, 2. It looks like these two functions are identical. They're doing exactly the same thing. Let's try this. Okay, x is equal to foo of 1, 2. Y is equal to bar of 1, 2. What's the first difference that we've noticed? Well, the second one printed, right? Because that function has an instruction to print something. So we were expecting something to print. What value is x equal to? Yeah, 1 times 2. What value is y equal to? Or what value do we expect y to be equal to? You see, there's a huge difference here. What is y actually? Okay, so now the question becomes, why is this equal to none? Well, if we look again at the what I wrote bar to be, it was this. And I said, whenever you write a function, you are obligated to write return. That wasn't entirely correct. If you don't write return, Python is going to write this in by default. So this is why it's returning none, right? If I say x is equal to bar 1, 2, what does it do? It prints 2 and returns none. So x is now none. Okay? We're going to go through like 4 more examples of this. But if you take anything from this lecture, it's that printing from a function is not the thing that you want to do. You must return from a function. Just because you don't see the function output something doesn't mean it hasn't computed something. Where we don't always need to look at the thing that's being computed. Like remember, we're on a computer. Just numbers are moving around in memory. Names are just sort of stand-ins for memory addresses. So again, I can do something like this, right? And some number has been put into x. We can look at it if we want, but it doesn't naturally print. Okay, so if you find yourself printing from a function, ask yourself, why am I doing this? Right? If you really want to see the output of your function, you should do this. Right? Print what the function is returning. Was that a question or just a stretch? I guess it was a stretch. Okay. So here's just a more sophisticated example showing that like you can like use these functions like repeatedly. So this may be a little bit harder to parse this, but if f is just multiplying 2 numbers together, what is x going to be? Well, f of 2 and 3 is 6, so this second parameter is going to be 6. 5 and 2 make 10. That's minus 10 plus 12 is 2. So this is going to end up being 2, 6, 12. All right, so you just have to see these as resolving, right? You can see this as being 6. Right? That's how we would treat it in math. There's no difference. Right? You can say f of 2 of 3, or you can put the intermediate calculation in, but ultimately we just care that that gets like replaced by 6. The thing that has been returned is what it's going to get set to. Oh, I've been neglecting the chat. What does the return exactly do? How does it differ from print? Well, I just went through a series of examples where I was showing the difference. Okay, so like I have more examples, so maybe those will flesh it out. So rather than repeating what I just said, we're going to forge forward, and if you're still confused, let me know. So return is a reserved word. The other thing I don't want you to do is this. Here, okay, def foo x, y, return x times y. So that first thing is good, right? This is yes. This other thing is no. No. So the second thing's going to work. Nothing's preventing you from calling return like a function, but it's not a function. And the way you can understand why it's not a function is, if return is a function, what word does it use to return? Like it can't be a function. Like eventually we have to hit something, which is an instruction to return to the user. Right? So if return is called like a function, then that just begs the question, what is it using to return? Right? So it's different. It's not a function, it's a keyword, which is a little bit different. So again, this will work, but you're sort of treating return like a function, which it isn't. Actually, while I'm in here, some other stuff. Yes, you want to call foo like this. Okay. No, you don't want to call foo like this. Right? And I guess if I call this f, it makes more sense, right? You would do this in math. Yeah? You wouldn't do this. right? So this is just sort of saying f is a function, and like the brackets are the thing getting put into it. This is going to work, but it just doesn't look right, right? The f should be attached to its input. Where did my thing go? Okay, and I've lost the chat. Okay. So what the return statement does is it ends the execution of the function and hands back to the person who called the function the value. Right, so again, f of 2, 3 goes in, computes 6, and 6 is returned. That's how that whole exchange works. Okay, so now we're going to like readdress all of the printing and return stuff again. I have a series of examples where we're just going to move this return up the ladder. So here's a very simple example function which takes one input x. It's going to print 1 times x, print 2 times x, and return 3 times x. So if I type this into my REPL, and you guys don't really work with a REPL, but it's the same Python, what will print and what will get stored in A? Like what will you see if I type A is equal to example 1?
2 and then, 1 and 2.
And what gets stored in A?
3.
Exactly. So it's going to print 1 and 2. Because like let's do exactly what Python does. Python gets to line 6. Well, actually, it's reading from top to bottom. It goes, I'm going to define this example function, which has the following contents. Sure, but that's not an instruction. This is just telling me to set up a function. So Python goes, okay, I've set up the function, so you can use it now. At line 6, I'm saying into the name A, I want to put in whatever this example function returns when it's handed 1. And what happens here? Python goes, oh, I know what example is. That's this. I should replace this x with a 1. And I'm going to print 1 times 1. That's this. Then print 2 times 1. That's that 2. And then return 3 times 1. So A actually is holding the value 3. So it was computed even though it wasn't printed, right? So again, we can do an endless amount of computations that are never displayed. In fact, we don't usually want to see the intermediate calculations displayed. We're using the computer to like do those calculations for us, so we certainly don't want to see it. Okay, so all I've done is move the return up 1, right? And remember what I said, return ends the party. Right? As soon as you return from a function, it exits. It stops doing whatever else. So if I say here, A gets example 1, what prints and what gets stored in A?
Print 1 and then store 3.
Print 1 and store 3. What about this? Yeah, that's correct. So this is going to print 1, and in A it's going to store 3. And let's walk through what Python has done, right? So again, it knows about this function because it's been defined. If I tried to do example 1 before I defined this definition, it would say, I don't know what this function is, right? So again, sequence matters. So it goes to example. It says this x needs to become 1. Great. Print 1 times 1. That's what this is. Return 3 times 1, and we're done. It leaves. It doesn't matter that there's stuff under return. Return ends the show. If this return was in an if statement, that's a different story, right? The fact that return was actually executed is the thing that ends it. It's not necessarily because it appears higher up. It was triggered higher up. So that's a nuance to keep, to be aware of. What is happening? Lag. Okay, 2 returns and a print. So what happens now if I try to set A to example of 1? What prints and what gets stored in A? Okay, so you say it's A stores 3 and nothing gets printed. Does anyone agree or disagree? Well, you all showed up to campus today to see me. You could have streamed this, so presumably you want to have a little bit discussion with me. But like, you got to tell me, it's like, do you really not understand what this is going to return? Because I'll explain it more. This is not going to come through osmosis, right? So if there's confusion, someone has to let me know. Okay, well let's walk through it again, right? And all we have to do is go line by line to see what happens. So this gets read into Python. And I say, okay, into A, I want to store whatever example at 1 returns. So this goes up to here. We were at example. X gets set to 1. We return 3 times 1. We're done. Right? It doesn't matter what's under here because we've exited the function. Nothing's going to happen. This return triggered. Right? So it doesn't matter that there was 2 returns here because we can't. Right? The Python has left the function already. So in this case, A is going to be 3. I don't exactly know why I did that. That shouldn't have appeared. I'll fix these. Oh, lag. What else? Yes, miss.
What is like, which one of those lines is us writing it versus like Python, Python? Does that make sense? Like, do those pink triangles mean that we're typing that in?
Yeah, okay, so this is a good point. So this looks a little bit different from, so this is Python. This is called the REPL, read, evaluate, print, loop. And it basically just lets me use Python like as a calculator. So I have these 3 chevrons here to just denote this is me giving an instruction to Python. And if I want to do something that's like over 1 line, 1, 2, 3, 4, you see that these dots appear. So in my slides, I'm sort of just like simulating what you're seeing there. So it's like everything to the right of that is what you would type into your Jupyter. But it's exactly the same instruction set. It's just hard, like what you're using to learn programming is like not really for development. It would be really difficult. I tried it in lecture 1 to teach from a Jupyter notebook and it all went to shit, right? Because that's not what its design is. It's really like a living document, right? Where you can have code in between. But for my purposes, it just doesn't go very well. But all you have to do to interpret this is to be like, yeah, this is what you would print, and just ignore those 3 chevrons and these 3 dots. I'm simply simulating what you would see in this Python shell. But everything I'm saying is totally true for typing into Anaconda. Although I appreciate, yeah, because you need to type very precisely. So to know that you don't have to type those 3 dots or those 3 chevrons is fairly relevant. So yeah, it'd look more like this, right? So here's a file. This is basically like your Anaconda. So I could do the same thing here. Right, and then I could say print foo 2, 3. And then my output will come underneath there. I just have to hit different buttons to get it to go, right? But there's your 5. If you put this into your Anaconda or Jupyter or whatever, it would do exactly the same thing as this. But thank you for asking for that clarification. Where were we? Were we here? No. Here? Okay. So here's a function. I remove the returns. So I'm going to set A to whatever example returns for 1. So my question is, what prints and what returns? Yeah, it's certainly going to print something because there's a print statement in that function. So 1 gets passed to this function, so x becomes 1. Then we're going to print 2 times 1. So that prints 2, but what is the value of A? Yeah, none. It actually will just show nothing. And so if I go into my REPL, x is equal to none. It truly is. Like this is a weird thing where it's x is none, but it doesn't display anything. Can I print x? None. Okay, so we'll print none. But if you ask for its value, nothing will show up. So that's why I never want you to write a function without return in it. You sometimes will write functions where you don't need to return anything. That's sort of called like a procedure. And in that case, I want you to write return none at the bottom, right? So not let Python put that in automatically. So when you're looking at it, you're not confused as to why this is returning none. This is one of the most common mistakes I see in beginning programmers, right? Swapping out return for print. And so there's a lot of questions on my other EdStem about why is my function returning none in all cases. And I don't even have to see their code to usually answer, are you sure you're returning and not printing instead? Because if you do this, so this is very common as well. Oops. So what happens here if I say z is equal to foo 2, 3? we can work this out, right? Look at print. What does that look like? Pardon me? Yeah, we'll print 5, but like, what does print look like, right, now that we're talking about functions? It looks like a function, right? Print is a function, right? That given input will put something on the screen for you. But it's a function that doesn't really return a value, right? I told you in Python, everything is a function, even if it doesn't return anything. So when I call print like x plus y, what's print going to return as a function call? None. So what's this going to return? None. Right? Again, because print, like we walked into here with 2 and 3, print got called as a function, it got 5, it went ahead and printed it, that's what it does as a function, but it also returned none at this level. So this now returns none. So this is another very common mistake. And they're hard to understand because it, like, at our level, it looks like it's working perfectly, right? This looks like it works. Yep, that's working, this is working, but then it fails at this level. If I say foo's, like z is equal to 2, 3, and s is equal to foo 1, 2, I expect to be able to do this, right? To get 8, but it all explodes, right? Because both of these things are type none. And so this is just really, really, I cannot express this enough, right? That print and return are doing totally different things. So just ensure that your functions aren't returning none. I don't speak Cantonese, or I guess I don't read Cantonese. No problem. Okay, so that we have there. Okay, so here's some like, yes, miss? That's for comparing things rather than, so remember, we have this equal, which tells me I want you to put into x the value 2. This is assignment. But like we also want to be able to say like if x is equal to y, like do something. Oh, I can definitely type today. Do something. Okay, but hold on. We already said that this is for assignment, right? So we're going to need a different symbol for doing equality checking. So we just do that. In other languages, we have this. I think that's the C way of doing it. But in Python, it's single equal for assignment, double equal for comparison. These are all good questions, by the way. Okay, so here's an interesting fact from math. If I give you a triangle and I tell you the length of its sides, this is actually the equation for calculating its area. Like you're used to calculating the area of a triangle given its base times height. But how would you do it if I didn't give you base times height, if I just gave you the side? So we have this formula. It's the square root of s minus a, s minus b, s minus c, where s is half of the sum of the perimeter. So this is like exactly something that we'd want to do as a function. Like suppose in your program, you need to calculate the area of rectangles given their sides. You don't want to have to write this every time. You just want to be able to call a function that says, here are the 3 sides, return the area. There's nothing stopping you from just doing that computation every time you need it, but that's pretty error prone. Like if I write this function for calculating the area and try very hard to ensure that it's working by writing like a million tests, right? That's better, because who knows, maybe like the 60th time that you write this in, you're gonna write it in wrong. So we're gonna be able to demonstrate a bunch of things on this example. So I'm gonna write a function. So the first thing we need to do is say def. I'm going to define a function. Now let's call this area of triangle, okay? And what do I need to give the area of the triangle? Well, I need to give it 3 sides, A, B, and C. And then I need to return something. So I usually just say return the answer. And then I'll construct the answer in between. This is just personally something that I do. So what's the answer? What do we need to do? We need to, okay, so I suppose the first thing that we should build is this S. Okay, I'm just going to move that to the right. Perfect. Okay, so let's get an S. What should S be? This was A plus B plus C divided by 2. Okay, and then what should the answer be? Well, okay, so it's the square root of S times S minus A times S minus B, S minus C. So let's just do that. So this is S times S minus A times S minus B times S minus C. And now I have to take the square root of this. So how do I take the square root? I don't think that exists, though, naturally. I don't think that's a Python. I guess, is it part of your PyLab? So, like, this doesn't exist. But maybe... Yeah, that's better. Okay, so I just want to check. Hold on. From PyLab, import everything. Do we get a square root function? Lord. Okay, we do. But I don't want to do it that way because we don't have to do it. That was a great observation, right? We currently have the tool set to take the square root of this. I'm just going to take this to the power of a half. And I hope I know there is one for integers and one for, so this should be about 1.4. Yeah. Okay, so there's the area of the triangle. And then I guess, you know, we can simplify it a bit. We really didn't. I think that's sort of pointless. Why don't we just put this here? Okay. So now I can just use this. So it's going to print the area of the triangle 3, 4, 5. Okay, this is a perfect right angled triangle. Its area should be 6? 3, 4, 5. Yeah, so it should be half the base times the height. So base times height is 12, half of that is 6. This is the other thing that I want you to do. I don't hit enter before I see what the computer is giving me. I myself ask, what am I expecting to see? Right? So then when I hit enter, I'm either like, yup, that's it, or, oh, I wasn't expecting that. Right? So you should always think, right, when you're here, what am I expecting before I hit enter? Okay, so I'm going to hit enter. I am expecting to see 6.0. Because even though these were integral sides, we did some float arithmetic here. So that's going to change everything to floats. I saw nothing. Why is that the case? This is weird. No, but that should have just worked. Oh, I didn't hit save. Okay, that solves that problem. So there you go. And like it printed 6. Okay, we can try another one, right? 33, 23, and 100. I hope these are legal triangles. We'll see. Not a legal triangle. So this is where this is interesting. Who knows what this is? It's a complex number. So I think this isn't a legal triangle. Yeah, I think the hypotenuse can't be greater than the sum of the if I have a triangle that's like this, the longest the hypotenuse could be is like the sum of the two lengths. So I can't be in excess of 56. 55? Okay, that's a more sensible one. 142. So, like, it's important to note that I didn't have to declare this S. Like, I could have gone into here, and we could have just replaced this S like this. Right? We could have got rid of that. And we don't even need this function. You could have just written in, every time you wanted to compute the area of a triangle, you could have done this. Okay? Like, it's equivalent in terms of, like, what you're computing. Like, I hope you can see that one of these things is, like, way better than the other. Right? This is not very readable. Right? This would certainly not be something that I want to see in various places in your code. Right? I'd much rather see, right? That's much more convenient. I'd much rather see in your code this. Right? Is there any, like, if you read line 8, it signals to you what's happening, right? Line 8, into y, we are putting in the area of a triangle with these 3 sides. Right? So the other use of these functions is for you to, like, insert English into your software. Right? So when you're reading through it, right, these things make sense. Right? I didn't call this F. I could have, but it's much better to call it area of a triangle. Right? So to make it more clear. Like we can write very lovely software with very English type of statements by just utilizing better names of functions and variables. Okay. There are ways to improve our functions using a feature of Python called type hinting. Now, this is a feature that's like half-baked at the moment. It's slowly being brought into Python. One of the nice things about studying computer science is you are basically at the forefront of new technology. Right? You're using Python 3.8 that like came out last year. Like you're really playing with the toy, which is brand new. The downside of that is like the functionality is sort of being fleshed out as we go. So I want to be able to, in math, right, we would say something like f is a function that goes from the real numbers to the real numbers, right? X goes to x squared. That's how I'd write it, right? Domain and range. We want to be able to like say the same thing here. Like it would be nice if I could say something like, well, I want to take a float. B should also be a float. C should be a float. And this thing should give back a float. Right? I'm adding a little bit of decoration to this, right? To give the reader of this function more information when they look at it. So now someone can read this function and say, oh, okay, this thing's expecting 3 inputs. All 3 inputs have to be a float, and this thing's going to return a float. Now that I've told you this, nothing is actually enforcing this rule, right? I can go into here and say area of a triangle, Paul, Verbic, Prof. Okay? It's not going to stop me from doing that. Like once it goes into that routine, it's going to cark out. So let's leave this one. I want to do a different one. So let's go back to this foo example where I had x, an integer, y, an integer. And I want to say this returns an integer. And let's say it says this returns x plus y. It's more illustrative here. So foo2, 3, like we expect this is going to return 5. But we would expect something like foo, Paul, Verbic. Like we would expect Python to say, hey, you set up this function so that it takes integers. You've passed it a string. But let's see what happens instead. Yeah, it did it. It just went and did it. Right? So nothing is enforcing the rules that you're putting here. And this is one of the philosophies of Python, that it's sort of it's user trusting. So we have these things called contracts. This is called a type signature, but another way of calling it is to call it a contract. So this is the contract between me and you, the person who's using this. And I'm saying, user of foo, I expect that you're going to give me 2 inputs. Both of them are an integer, and I'll give you back an integer. If you don't give me 2 integers as input, you have violated the contract you have with me, and you now you have no assurances that this function is going to work. Yes, miss?
Is it kind of like on the left side of the arrow is your duty, and the right side of the arrow is like Python's duty?
Yes. Right? So that's actually really well said. So I'll repeat that for the chat. So one of our students said, it's almost as if the thing on the left-hand side of this arrow is the duty of the user, and everything on the right-hand side here is the duty of Python, by which you mean us, the programmers, right? So it's funny because we're both users of software and creators of software. But when I'm typing in functions, I'm the developer, and when I'm using that function, I'm the user. But the point is, nothing enforces this, but you can violate that contract. And in fact, this kind of works, right? It is adding 2 strings together, but it sort of falls out of what we're telling it to do. Okay, so we can add this sort of type hints. What else can we do? Okay. We also want to put something here called a doc string. Okay, so those are 3 quotes, 3 quotes. So here, you can type anything, right? So this is sort of like comments. And this is a special type of comment where you want to say something like, computes the area of the triangle using Heron's method. And then maybe you want to give some usage examples, like, area of a triangle, 3, 4, 5, that should be 6. And I'll just do the 1. So this is called the doc string, and you usually want to put at least 2 things in, like a description of what the function is doing, not how it's doing it. If I want to know how the function is doing it, I'll just look at your code. That's a perfect description of how you're doing it. At this level, you want to tell me what it's doing. Okay, so why do I want to know that? Well, check this out. So I'm in Python, right? And now I can actually ask for help on the area of a triangle. And it says, here's your help, right? This is a function which computes the area of a triangle using Heron's method. Here's some usage. In addition to that, this is something called the doc test. And I can actually tell Python, go and actually check that my function does that, right? And if it doesn't, it'll say, hey, you either screwed up your usage example or the function itself is broken, right? Which falls into this category of testing. Right? You always want to have like a series of tests so that if you change something, you know if something's broken. So here, this may be sums, the 2 inputs, usage, right? Foo, 1 and 2 gives me 3. Foo minus 1 and 1 gives me 0. So again, this will allow us to say help on foo and get some information. In fact, like you can ask for help on like many things in here. What's something that you guys should know? Help on lists, maybe? Anyways. You can always type help and get help along anything. Okay, so that's another way we can decorate our functions by putting in a little bit of extra description. What happens if you put the wrong output? Nothing. Right, so I can put the wrong output here and like nothing will happen. Except we're going to have a really not the greatest area of triangle. Right now, that's what our used example is. So that's from the chat. Again, there's something called doc test, at which point it would tell you, hey, these things don't match up. But I don't think we're going to talk about testing at all in this course. But you should try and write these doc strings. Right? You should always try to write in such a way where you like assume someone else can look at it and needs to understand it. Okay, so this is just like a generic framework for how like your function should look. It's def, then give some function name, and remember we have like conventions about like what type of names we're allowed to use. So for functions, it's a lowercase. This is not called camel casing. I forget what this is called, where it's divided by 2 by underscores. I think it's bucket casing or something. But anyways, if you want to have like function name, it's function underscore name. And then you have an arbitrary number of input arguments, right? So argument 1, and then it's colon, and then it's type. There should be a space there. I can fix that too. And then this arrow indicates I'm going to return this type. Can I ever return more than one thing from a function? Dante says, yeah, a tuple. Does anyone have a response for that? Am I really returning more than one thing from a function if I'm returning one tuple? No, I'm not. Functions can only return one thing. Now, we can trivially return a bunch of stuff by putting brackets around it, but we're still returning like one thing, just with brackets around it. And so that's pretty important. It wouldn't make sense for a function to return 2 things. Right? We'd need like a return left, return right, or something like that. Okay, why not? So for my other class, I'm insisting that they sort of review this document, but I don't think it's overly necessary here. But because we're writing code, presumably for other people to use, there is a series of agreements of how our code should be styled. Like when I say your function name shouldn't have capitals, that's just sort of an agreement. Like no one's going, if you want to call it foo with all capitals, Python's not going to stop you. It's just not part of our convention. If you want a comprehensive list of the conventions we're using, you have to look up this PEP manual. And PEP stands for Python Enhancement Protocol. And everyone's constantly arguing about what and what should not be standards. But we're actually using Google's PEP. Now, when you download these slides, these are buttons. Well, let's go and see. Oh, yeah, but then I'd have to share it. So you can click it, and then you would see, right, if you want to break lines, you should do it in the following way. So I'm just going to tell you some of the more important type of agreements. So variable names and function names are like this, right? With underscores, lowercase and underscores, and not like this. So words like this, those are called camel caps. That's actually reserved for declaring new classes, which is not something that you need to know. But you do need to know that if you write something with camel casing, any other Python programmer is going to assume you're like manipulating a class, which is not the thing that you want to do. If you want to break long computation across lines, you want to align it like this. You may also have to put a backslash to indicate that you want to go to the next line, but this is how they're telling us we should line them up. Comments, make your comments useful. So surely by this point you know that if you put a hash, anything subsequent to that hash is not going to be read in by Python. It's going to say, I'm just assuming you're writing English, I'm going to ignore it. To say that this line is incrementing x is totally useless. Yes, you are incrementing x. I can see that you are incrementing x. Like, you have to assume the people reading your code are like competent in reading Python code. So don't tell them what the Python code is doing. I'm more interested in like, why are you incrementing this x? It's like, oh, I need to compensate for some border, so I'm going to increase. Okay, yeah, that's a lot more sensible comment, right, than the thing before, right? And don't go crazy where you're starting to write comments that are like longer than the code that you've written, right? The comment, like you're using English, that's a little bit more compact, like more expressive, right? So your comments are there so that if you've done something weird, that when you return to, you're going to be like, why the hell did I do that? Like that's why you put a comment. Spacing. Left-hand side, yes. Right-hand side, no. So we usually try and like use spacing to emphasize order of operations. Right? So here this is sort of saying, look, like the 2 and x are going to multiply before this -1 happens. Same thing for here. Right? Again, it doesn't matter. Python is going to accept any of these things. This is just a way of making your code look more clean and easier to read. So in summary, blocks of code can be grouped into functions. Functions can take 0 or more inputs and hand back a single value. Oh, maybe I should just, do that. We don't actually need to take any input. Not very useful, but just to show you, you don't need to take input at all. So, next week we're not doing selection. Next week I think I'm actually showing you how to use the plotting software. And then after next week, these are just going to be for, working with me personally to sort this stuff out. So please, again, come to those lectures prepared with questions. Otherwise, I'm just going to sit here and drink coffee. I'm not going to prepare anything. So that's it for today. If you have any questions, ask them. Otherwise, you guys have a fun weekend. Enjoy being outside. Be kind to one another. And be grateful. Have a nice one. Bye, chat. See you later, Shannon. Bye, Luke. Bye, Mr. Luo.